or NMR. Sorry. Welcome back to the NMRA Gateway X. I'm here with the next presenter, Dr. Michael Groves. He trained as a physicist and worked in the medical field all his life, first in development, then sales and marketing. Becoming frustrated with the amount of wiring involved to provide even a small level of lighting drove him to using his physics skills to develop a novel way of lighting without wiring, using fiber optics. Darwin Enterprises was formed in April of 2018 to commercialize the idea in his family business that involves his wife, children, and grandchildren. Please welcome Dr. Michael Groves.
Thanks very much, Brooks. It's a pleasure to be with you this afternoon or this evening or whatever time zone you're in. I just want to give you a quick sketch. You probably see the name there, Darwin. My grandson actually came up with the term. He loved Tolkien, and we were driving one day and he said, we talked about what we name this company, because he was starting to work with us, and that's how it all came about. Today, actually, I'm going to talk to you a little bit more about the science of lighting a little bit. So I hope we won't lose too many of you. And then I'm going to talk about how bright do you really want to light on a lighting layout, and also things like, what's the spacing you should use, what type of lighting, divergence of beam and stuff like that. And then we're going into some examples. There's a short video on how to light a house using fiber optics. And then we'll move into some of the newest stuff, which you've seen a little bit of earlier today, which is the animation unit, the Lamplighter FL, as we call it. And we'll talk a bit about that, and then it'll be over to Q&A. But this one is, oddly enough, it's not going to be strongly commercial. It's going to be primarily looking at a bit of science, and I hope it'll be helpful to you. So let's get going and let's run. Well, very much for talk to you at this conference. Here to talk something about how to light your hobby, and I'm to talk about designs and tools for that. Last time I talked about our fiber optic system that we've developed with the Darwin system and the challenges that I faced in developing that, and the success we've had with that. So today let's talk a little bit about, for example, the issue of illumination or visibility. When you're trying to put light onto something, the question is, do you actually want to really illuminate it, or do you want to just have a visible light? So for example, if I was to talk to you about looking at these lights on the trains, clearly those are going to want to light the path in front of the train, just as a car headlight does, just as a street light does. And for that, we're going to need something in the 100 lumen type of range. On the other hand, if we're just looking at a light at the back of a train, or we're looking at a flashing light or something like that, we do not need nearly the same intensity. Instead, we're really looking at just sort of visibility of a light there. And we can deal with something that's even less than 10 lumens. So we can have something that's 10 to 100 times less intense than what we're going to need for illuminating something. Let's take a look at what are the units of measure for an object, and typically you're going to see this on your packages. You go into Home Depot, Walmart, wherever. They're going to be packages that talk about having, say, 350 to 700 lumens. Well, as you can probably see on this slide, if you compare that with the sun produces 6.8 by 10 to the 27 lumens, or in other words, 6.8 billion lumens. Now, clearly, that's a huge contrast to the amount of light you're going to get out of a little light bulb. And so in order to be able to compare light outputs, we really don't need to want to talk about lumens. We're going to talk about lux. So let's see what that's all about. Lux is really taking the number of lumens over a square area, or a square meter, for example, is the way it's defined. So now, if we take a look at the sun, it's between 10 to 25,000 lux. On an overcast day, it drops down to about 1,000. If you're looking at, say, the light from a moon, it's just 1 lux. If we're looking at a room, like a living room, typically it's 100 rather to 200 lux. And then street lights are going to run somewhere in the order of 200 to 1,000 lux. So now we've got a measurement that's a little bit more comparable than just looking at the number of lumens. Well, why is it so important to sort of understand this area a bit? And that's because people sometimes come to me and they say, well, why don't I just buy your fiber and I can put it with one of my 10 milliamp LEDs and maybe we can light something that way. And the issue is that that's just way too little light and it really won't illuminate something. So we're going to talk about how much light do you really need to light buildings, to light streets, and so on. So let's get into that right now and talk about sizes of street lamps. So if we're looking at a small street lamp that's, say, in a park or on a small walkway, we're talking something that's about 3 to 4 meters. In other words, just over 10 to 12 feet. If, on the other hand, it's more of a street light, the cars going by, we're talking about something that's in the 5 to 6.5 meters high. So here we are, 15 to 18 feet. Or if we're looking now more at a highway type of lamp, now we're at 6.5 up to, say, 10 meters. So we're actually up into the 30-foot type of category. So clearly, the size of a light, the height of the light, is very important to know because it depends on where you're actually going to be placing it. Here's just another example of the different sites and heights of lamps that you're going to need. Well, when we look at the specifications for these lights, real street lighting specifications, we're going to start with the amount of wattage and then go to lumens. Then we're going to have the height of the light, the beam angle, and eventually we'll calculate the lux. Well, why do we need all those parameters? Well, it's all of those parameters that eventually give us the amount of light that's coming down to us on the surface. So let's start with probably looking at the beam angle, because this is a very important parameter in lighting. So beam angles are defined really by the spread of the light, as you can tell, over the certain angle, and it's the complete angle that it's spread across. So for example, here's an example where a beam is only 30 degrees on one side, but it's a spread of 60 degrees total. Now I'm going to do a little bit of maths, and hopefully I won't lose you. It's pretty simple stuff. It's a tiny bit of trigonometry. So here we go. So let's take an HO scale lamp, and it's 5 centimeters high. So that's the height of our lamp that we've got. What we need to do is we've got the Y, which is the high part, the height of it. We really need to know how much that light is going to spread. So I need to know something called theta, or the angle of spread, and then I'm going to want to know, that will allow me to calculate the value x. So if y is, say, 5 centimeters and the theta, or the angle, is 20 degrees, then I take the tan of that angle and I end up with an x of 1.8 centimeters. So that little calculation allows me to know how broad will that beam spread out to. Well, the area, as you know, is pi r squared, so we multiply 3.14 by that 1.8 centimeters squared, and we end up with something like 19 centimeters squared, but we're going to convert it back to meters. Now we're back to 1.9 by 10 to the minus 3 meters squared. So that's a pretty small area. Now, take those calculations, and now if I've got a light source of 1 lumen, then my light intensity over that area would actually be 526 lux. So in fact, even though the moon is only 1 lumen as it comes down to us, if we're looking at the spread of a light, say 20 degrees, which is really a spread of 40 degrees total, and look at the light intensity, we take that number of lumens, divide it by the square that it's going over, the area it's going over, and that'll give us the actual amount of lux. So now let's get into some real life. Okay, so here we go. So here's a what's called a Clermont luminaire. It's just a lamppost. It runs at 70 to 100 watts. It's designed, as you can see, as a street light, really. And so let's take a look at what happens if I take that and I change the height or I change the beam angle. Let's take a look at the amount of light that I get. So here we go. So I'm going to take a light that's got 80 watts to it, and I'm putting in a pretty powerful bulb into it. So I've got 1,200 lumens coming out of it. If my height is 3 meters, that's 9 feet, right? We talked about that's more of a park light. And the beam angle, now let's vary that. Let's vary that from, say, 60 degrees out to 100 degrees. Well, I'm just sort of blanking out a bit the radius and the area calculation just to drop to the bottom line, which is that the number of lux we would have on the ground would be 127 lux with the 60 degree spread and about 30 lux with the 100 degree spread. So you can see that the angular spread has a huge impact on the way in which we're actually, how much light we're going to get. So let's take another one. Let's take a street lamp. Its wattage, say 250 watts. Here it is 3,750 lumens, huge amount. 5 meters high, it's about 15 feet. But I take the beam angle. Now let's take a beam angle of 40 degrees or compare it with something that's 160 degrees. We've got a very, very big spread. And what you would see is that the amount of lux you get is hugely, hugely different. In one case, you're getting something around 360 lumens for something like a swan neck lamp, but a carriage lamp, which in fact is spreading the light right around an area, is going to give you far, far less light down on the ground. So only 1.5 lux. I hope that made sense to you, so you can sort of start to see that the spread of a beam is extremely important to know, because it'll affect very much how much light you get when you're illuminating something. So for example, here's the Cobra headlight that's typical of many of the lights on highways, and here it is. It's about a 30-foot light up on a pole. By the way, I take most of these images from places like Jersey Central Lighting or other places off the website, so you can find all this information very easily. So let's take that. So here we go with a highway light. Say a 250 watt gives us 3,750 lumens, but the height now is 10 meters, so it's about 30 feet. And again, if we change that beam angle, even by a fairly small amount, we change the amount of lux down on the surface, on the ground, considerably, from something like 36 down to 17 lux. So once again, the spread is very important, but also one of the things you'd see is these highway lights, while they're fairly intense, because they're so high, they don't actually provide that much illumination. And that's obvious. The reason for it's obvious, because you're driving a car down the road, you've got headlights on as well. You don't need the type of illumination that you have in a park, where you're walking and you're going to trip over things because you're not walking down with a headlight beaming from you. You're typically just walking using the ambient light that you got, or the light rather, from the park lighting. Okay, so hopefully I haven't bored you completely, but now I wanted to get to something that was rather fun. So what I did was I took my light meter, actually my phone, and I loaded it up with a software called the Lux Light Meter. And what that allowed me to do was to be able to look at the amount of lux that was coming onto my my phone. So I went down the street, and down the street we have these what I call Acorn street lamps. That's in our development, and the results that I got from that were something in the 270 to 320 lux of light was actually coming down. So actually quite a powerful light, because that spread over quite a large area. So the next thing I did was I decided, well, I want to put this now on my own layout. So here we go. So now I'm looking at a street lamp. This is a swan neck lamp that you see that's near a building. And you can see that actually what I'm reading there is 183 lux. Well, that's fairly similar to what I'm getting out on the streets in the area of our neighborhood. So that was fairly comforting to me to know that, oh, that's pretty indicative of that I've probably got some pretty phototypical lighting. So I then did another one of my swan neck lamps, which was just around the corner from that. And once again, I've got lighting that's in between the 150 to 200 lux range. So we talked a bit about it. The directionality is very, very important. So the choice of the type of light and the technology you use is very important to understanding how much light you're going to have spread. So if you took a globe lamp, it's going to spread light over 360 degrees. Take something like a carriage lamp, it's got a top on it, it's only going to give you something like 180 to 160 degrees. A swan neck lamp is down around the 40 to 60 degree range. And then a highway lamp is actually fairly intentionally focused down to something like 60 degrees typically. So we're going to talk now about the directionality of lighting on models. So your choice of lighting could be, for example, a grain of wheat bulb. Now, a grain of wheat bulb gives you light over about 180 degrees. So it's really quite wasteful in a way. And what it does is it gives you a lot of glare unless you really put something hooded over the top of it. But what it also does is it uses a lot of energy and doesn't put the light where you really, really want it. Well, let's move to LEDs. So an LED without a lens gives you about a spread of 135 degrees. That's quite broad. If you put a lens on it, you can actually get that down quite below 90 degrees, which is attractive. And again, if you put it in a globe, you get something around 360 degrees. Fiber optics, on the other hand, without flaring it, is going to give you a much narrower angle. And I'm going to get into why that is in a moment. But it's down at about 40 degrees is the spread of that light. If you take it, if you flare the end of the fiber, you can increase that to around 60 degrees. And then if you put it in a globe, you get the same as you would with an LED, so around 360 degrees. So the spread of your light is very, very important, especially when it comes to street lights, as to how well it's going to light something. So for example, there's a typical spread for an LED. And what that does, so this one's showing you something like 120 degrees. The challenge is sometimes I'll go into train layouts and I'll see some really bright lighting, but I'll also see that it's dazzling a bit and it's distracting from the ambience of what I really would like to see. And because of that widespread, that's one of the reasons why LEDs can tend to be rather dazzling. So of course, what you can do is you can reduce the intensity of that, but you're going to have to use a resistor in series with it. You'll already have one probably in series with it so it doesn't blow out, but you're going to have to change that. And obviously that's a bit of a faddle to have to modify it. But you can do that. Now, how about for the fiber optics? So fiber optics has a spread, as I say, of about 40 degrees. And so it tends to have a much more focused beam to it. So let's talk about the spread of light from a fiber. Fibers are naturally more directional in their lighting than an LED. They have what we call a numerical aperture of 0.5. Now that's probably pretty meaningless to you. It was to me years ago. But it translates into an acceptance angle of about 30 degrees. So light coming into a fiber, if it's more than 30 degrees spread, it won't go into the fiber. Only if it's 30 degrees and less than that will it get into the fiber. Now, one of the advantages with the fiber is that it's trapped inside the fiber, and that's why it goes around bends. It can travel long distances without much attenuation of the light intensity. But at the air-fiber interface, or the fiber-air interface, I should say, the light refracts, and you end up with that spreading of that 30 degrees over to about 40 degrees. And so what happens is, though, there's far less glare from fiber lights than you would expect. Now, I have to say, when I first came across that with my own fiber lights, I thought, oh, that's not much of a spread. It's very disappointing. So I talked to some of my customers, And they said, no, Michael, that's exactly what you want. That's much more prototypical than having something that's sort of blaring light out and giving you a glare. So I actually had lucked out on that, I would say. I just want to go back to this idea of refraction, because you know about it, really. So we took this pencil and you looked at it in the glass, you would see it going from the air to the water interface. It looks as though it bends. Well, we're going to look at this in reverse, because obviously coming from a fiber, that's a higher density like water. Going into air, what happens is the light's coming up there, say at 30 degrees. As soon as it comes into the air, it bends and goes and spreads a little bit. So that gives you some idea as to what we're talking about and why it happens. So a little bit of the physics behind fibers. Now, one of the things I just want to show you here's a little farm. On the left-hand side, I've got a carriage lamp that's actually covered with a top, and you really can't see it from the top perspective. As I go to the right picture, I drop down a little bit, and now you can really see that fiber, that carriage lamp glowing quite nicely, but without any glare to it. And that's one of the features that I've found that people really like about the fiber optic lighting, is you end up with far less glare and a much more prototypical lighting. That's not to say you can't do that with LEDs. Of course you can. It just requires a bit more work. So let's translate all of this into real life, from real life rather, to scale lights. So here's a bit of a chart. So remember, we've talked about the sizes of lights. We go from a path to a street to a highway. 12 foot, 15 foot, 30 foot heights. Well, if we look at those in terms of different scales, I put the scale ratio at the bottom there. Some of you may argue that you don't like those scales. Okay, that's fine, but they're roughly okay. So if I was making a light for a path for an N scale, I'm going to be ranging from 1 inch high to only 2.5 inches high. I must say, those 1 inch high lights are quite difficult to make, but there we are, we make those. Going to HO, we've got a little bit more latitude. Now we're going from 1.7 up to, say, 4.1 inches. If I'm in narrow gauge, larger, and then in O gauge, obviously quite a bit larger in height. Now, the ones that we actually produce, I'm only focusing for a moment on the Dwarven ones, the ones with the fiber optics. We have a globe and a swan and a highway lamp, and so you can actually see those are matched more into the path, street, and highway. And if you look at the height of those, they're actually matched fairly well to what you would expect if you were scaling them from real street lights. So I want to talk a bit again, go back to the idea that the wider the spread of the angle, the greater the distance needs to be actually between the lights, because you just don't need them to overlap. So real world recommendations are, for example, that if you have something like a street light, 13 foot high, spacing should be about 65 feet, with the sort of those Cobra lamps that you have on the highways. Then the spacing, it says spatting there for some reason, 125 to 150 feet. And so a rule of thumb that designers use, that's designing our roadways in the United States, rule of thumb is a 5 to 1. In other words, it's 50 feet spread for every 10 feet in height. Well, now I'm going to just do a bit of an examination of what I did on my layout to put some lighting in. So here we go. So what you're seeing there is my street lamps. You can see they're actually the swan neck, and you can see they've actually got that quite tight focus. That beam spread is only about 40 degrees going around that traffic circle there. And so there are some darker spaces, which is what you would expect. So let's take a look at the sort of spacing we might expect to have on these scaled lights. So we've talked about the path, street, and highway light in terms of their height. So now I want to talk about the spacing. So if I'm going to focus for a moment on the HO. You can see if you're looking more at N or narrow or O gauge what the measurements would be. But in HO, for example, then the spread should be 8 inches, 10 inches, and up to 20 inches even for a highway. Well, you possibly noted in my picture, I wasn't quite to that scale. So let me show you. So here's my HO scale spacing. My light height is about 1 3/4 inches, equivalent to 12.5 feet in real life. My spacing, on the other hand, is 4 1/4 inches, which is equivalent to about 30 feet. And that's quite a bit closer than that which was specified, which was 8 inches, as you saw from that 5:1 ratio. Well, let me give you another example. And now we're on a waterfront. So this is my waterfront with my softer glowing globe lamps on those. And what I did was I then put a ruler behind those to be able to look at, okay, so what's my spacing there? So the height of these bulb lights is about 1 3/4, again 12.5 feet. The spacing is only 5 inches. That's equivalent to 25 feet. And I'd expected to, if I use the 5:1 ratio, I should be spacing those about 8 1/3 inch. So I've actually spaced those quite a bit closer. Let's take a look at the highway. So here we go with the highway lamps. And again, you would see this is a real design that's taken from Colorado Department of Transportation. And you can see the dark spots between those lights. Once again, you don't want to light the whole road up because you've got cars with headlights, right? So, and these lights are 30 to 40 foot high, so that's 4 to 5.5 inch in HO scale. So here's my overpass that I've got, and I've got some highway lamps on those, and the spacing on those I use, well, the height of those is 4 feet, so they're about a 30 foot high light. Spacing is 8 1/4 inches, and that's equivalent to 50 feet. But that's closer than the 20 plus feet, or 20 plus inches rather, that I would have calculated based on that 5:1 ratio. So I'm going to have to go to a new spacing rule of thumb. I believe that it's better for our application to reduce that real world rule of thumb from about 5:1 down to about 2.5:1. At least that's the way it looks much better on my layout. You may differ, but that's a rule of thumb that I would suggest to you. So that's sort of one of the big take homes from this talk, is when putting your lights in, take the height, multiply it by 2.5, and that's probably what you want as the spread between your lights. So in other words, if a lamp is 2 inches high, space them about 5 inches apart. All right, we're going to move to another subject. How about lighting rooms? Okay, so we've talked about street lighting, but now I want to talk about lighting rooms. So let's take a lighting of a typical living room, 12 foot by 18 foot in real life, at about 20 square meters. Well, in scale, that's equivalent to, in HO, to something that's about 26 centimeters squared, or 0.0026 meters squared. So let's talk about then putting some lighting into that. So typically a living room would have about 10 to 20 foot candles, they call it, or 1,000 to 2,000 lumens total. The area is about 20 meters squared. So we need about 50 to 100 lux, right? Because we're going to take that 20 meters squared divided into the 1,000 to 2,000. And that's the amount of light we're really going to need in there. So with the room, if it's only 0.0026 meters squared, I need something about 0.13 to 0.26 lumens in order to get that level of lux. So let's take a look at what happens with an LED. So with an LED, let's say it's a typical 10 milliamp LED at 3 volts is going to be about 30 milliwatts. And they put out about 20 to 30 lumens per watt. So we're now, if I calculate that through, I end up with about half a lumen for a 20 lumen per watt light, or maybe up to about one lumen for the brighter ones, the more efficient ones. So basically I've got half to 1 lumens output per LED, and that's really more than enough light. If we just go back one slide there, if we're going to need 0.13 to 0.26 lumens, then I could light between 2 to 4 living rooms with a single LED. Well, how does that compare with, say, the lamplighter system we have using fiber optics? If I took an HO living room using fiber optics, the lamplighter one puts out with a 1.5 millimeter fiber about 2 lumens. So it's actually quite a bit brighter than you get from a typical LED. Again, it's much more directional as well. So it's equivalent to about 2 to 4 LEDs, as I say. So it should light a room about 6 to 8 living rooms. And so that's why I recommend, well, I would only recommend using, say, a 1.5 millimeter fiber for lighting HO buildings. If I use anything bigger than that, I've got way too much light in there. Here's an example of a building that I lit. It's got several rooms in it, and it's got 3 fibers inside this English-looking pub. And you can actually see inside the living room there's tables, chairs, and carpet and so on. People enjoying their beer and so on. You've always got to have an English pub, at least in my mind, on a railroad. That's called the Wet Whistle, named, my wife gave that name. So here are some other ideas, the lighting that I've got on my layout, just for a moment. Some lighting of the buildings, you can see there. In fact, now there's one where I've not got the lights on at all and pop the lights on, and it really makes quite a difference. Actually, I love the little guys who are digging there. A little light gives them a lot of, pops them really out. But in those buildings there, those industrial buildings, I've got 3 fibers again in those, and I've actually got those in the upper level because I didn't want the lower levels at this time lit. So actually, let's just turn now to, I'd like to briefly show you how I'd light a building, and we'll do that through a video. Well, hello. So I'm Michael Groves, founder of Dwarven Enterprises, and today we're going to talk about lighting a building. Many customers ask me, what's the best way to light a building? So here's a building that I put together some time ago, but I want to add some features to it that are going to help me in the lighting. First thing I want to do is I'm going to put some aluminum foil. So I've got some aluminum foil, and I'm actually going to take some of that, and I'm just going to put that on the ceiling. Now I put some tacky glue, which I find very useful. Tacky glue, I've just put some of that onto some paper toweling, and I'm going to put that on the non-shiny side. So I'll just dab on a little bit of glue onto that, and I'm going to stick that up onto the top of the building. Of course, I have difficulty getting it in at first because my hand's a bit small. So there we go. All right. So I'm getting it in there. And it really doesn't matter how it goes in, as long as it gets up there onto the roof somehow. There we go. Good. It's not a perfect job, as you'll see, but it really doesn't matter so long as we've got a nice surface to work with. Now I'm going to put another piece of glue, aluminum foil rather, on the back of it. Let's just get some more glue out. Excellent. Okay. Good. So again, I'm going to take the non-shiny side, and I'm just going to put some glue onto the back of that. I'm going to put some, so I really, because this is not a fine science, I'm just going to really end up with glue in various different places on this piece. And then I'm going to just take that, and I'm going to put that down onto the back of the building. Okay, good. Excellent. All right, so now I've got some foil on the back and on the top. The next thing I want to do is I really don't like being able to see directly into a building. So what I do is I take one or two things. I could take some parchment paper, or I could even take some tissue paper. Both are equally good. And the first thing I'm going to do is I'm going to take some crayons, and I'm just going to draw on this some colours, because I really want to have an effect of curtains on this piece of paper. And I might add a little bit of extra color over here just to give some extra striation so it doesn't look too plain. And that's going to do it for now. So my next thing again is I'm going to put some glue onto the back of this paper here. So here's my glue. Okay, good. So I've got bits of glue onto that. And then I'm just going to stick that onto the back of my building. And there we are. So I've got this on the back of the building now. I've actually added some other colors. And so now I've got windows that aren't opaque, but at least they've got a bit of tissue behind them and some color. Well, let's take this over and put this on the layout now. So now we're over at the layout. I've got a number of houses that are already in place, but I really would like to work on this house, putting this house in this place over here. So first thing that I've done is I've drilled a hole and I've put some fiber in here. You can see this fiber here. I put a little bit of a bend on it, so you can see that I like to bend my fiber a little bit. It keeps in place. If it doesn't stay in place, I sometimes will put just twist tie on it. But the reason for putting this other piece in, this is just a stirring straw, which I place in, and it just keeps the fiber very straight, which is very handy, and allows me to really sort of, with some degree of friction, position the fiber where I want it. So here we have the light already there in the building, and we're now just going to take the building, put that over the light, and see how it works for us. So there we go. Put the building down. Okay. And as you can see, we've got actually plenty of light there. In fact, probably almost too much at this point. So we could back that off by removing the fiber a bit from the lamplighter box. So now you can light your buildings. Indeed, it's lighting without wiring. Thank you for watching this. Now, I'd like to show you some pictures from some of my customers. This was Mark Jewett. He was lighting a train station. Again, that's just using a single fiber inside there. Very nice lighting on a church building using some street lights as well as a fiber to give you a really nice glow on the church. Here's an example of some buildings, again, a couple of fibers stuck inside those buildings, and some parking, actually using the highway lamps to light a parking area. So again, you don't need that much intensity, but it's a nice night effect. Or here's some street lights, courtesy of Malcolm Sokol. And one of my favorite ones that I received from a customer actually is from Steve Juranics, Canadian, and he lit up this building using that system and using a number of different fibers to light those buildings, including the signage, and that was quite a work of art. Of course, we didn't talk about lighting your police cars, but there you go. Easy to do with a fiber. Well, how about lighting an N-scale room? Let's move to N-scale for a moment, because there's quite a number of N-scalers out there, I know. So if I was using fiber optics, my light output is proportional to the diameter of the fiber. So let's take the ratio of an N to an HO room. It's going to be about 1/3 that of an HO size room in physical space. The ratio of a 1mm fiber to 1.5 is actually 0.44 in terms of the amount of light that comes out of it. So a 1mm fiber would actually light about 8 to 10 living rooms on the N scale. I hope I didn't lose you on that. But I should have gone back to say that the light output from a fiber is the square of its diameter. So that's why going from a 1 to 1.5, square 1.5, that's 2.25, and divide that into 1, you end up with 0.44. So that's how I got to that. But that's why I would recommend only using a 1mm fiber to light N-scale buildings. A 1.5mm is just way too much light. You can always reduce the intensity by pulling the fiber slightly out of the light box, but why go for the larger fiber? The smaller fibers are easier to handle anyway. So here's some pictures. Here's one that I really enjoy from Paul Bocadero. It's N-scale. He's actually lit up a cinema with neon lights, actually. That's another topic for another day. but lovely lighting, gentle lighting on the street there of those buildings. There's one using some of the N-scale carriage lamps as well as the buildings in the background, and you see the movie theatre back there as well. Moving to Paul McCarty, he's lit up some of his scenery there. Very nice lighting of his buildings. And one of my favourite shots of all time is this rather ethereal scene where he's actually used fibres to light the backdrop in the area, and obviously got a number of street lights in there. It really looks as though a storm is brewing. Well, I just want to touch on one of the reasons that I moved from LED lighting to fibre optic lighting, because it is important. And that was because of the amount of wiring. And I really wanted to have a no wiring solution. And it was interesting. I was looking at Evans Designs and I liked some of their stuff and I was thinking of buying that. And then when I looked at the pictures of the wiring, I thought, oh my gosh, if I go through all of those lights and I got all of that wiring, it's going to be a nightmare for me. Getting older and I can't see quite as well as I used to. Soldering, more solder drops on my ankle than goes onto the wires. So that was part of my strong reason for moving to fibre optics. So that's why we have a no wiring solution using fibre optics. We have there the Lamplighter 2, that's the big brother to the Lamplighter 1. More light, about 50% more light than the Lamplighter 1 and twice the capacity. But we're finding a lot of N-scalers are buying that to put in their lights both in the buildings as well as the street lights, just because they can put one unit in and cover their whole scenery. Well, people have always asked me at shows, how about animation? Well, we're just coming out the next month or so with what we're calling the Lamplighter FL. FL stands for flash, but it's really an animation device. So what it does, in fact, is it allows you to have animation without wiring. So we're putting fibers into those, and it has 3 modes to it. On, off, which are obviously useful for block control lights, flashing, so that's useful for railroad crossings, emergency vehicles, whatever else you want. Blinking, so for example, the top of a control tower, high buildings, some of the road signs where you just want a little blip and so on. So you can have all of this different functionality. It has 8 ports to it, and 16 actual LEDs are able to be fit into this device. But one of the nice things is we're actually coming out with it has triggering on it as well. So you can actually detect a train coming by and it activates the animation box for you. So in fact, let's just take a moment and take a look at its effect on a railroad crossing. Introducing the Dwavin prototype Lamplighter Flasher unit. It has 16 ports providing both flashing and blinking functions, all though using fiber optics. And of course, one of the most obvious applications is for railroad crossings. Behind it, you see the lighting in a farm using our Lamplighter 1 box. So now both constant high-intensity light can be combined with intermittent lighting using fiber optics. So look out for more information about this fiber optic system in the weeks to come. So here is a range of products. As we go around it, we've got the 2 different Lamplighter 1 and 2. Now we'll have the animation FL Lamplighter. We have a range of different street lamps, carriage lamps, globe lamps, swan neck lamps, industrial building lamps, highway lamps, different sizes of fiber. We have also the billboards as well, which we've recently released. And then we have fiber connecting kits. So basically, we've now provided, I think, the opportunity to have a lighting without wiring solution, both for illumination as well as for animation. Remember, we started talking about that in terms of just the visibility, just be able to see a light. So we can cover all of that now with fiber optics. We just put an advertisement's just come out in Model Railroader in the August issue, and actually for the month of July, the Lamplighter are going to be 15% off. That's the Lamplighter 1 and the Lamplighter 2 boxes through the month of July. Well, I have to leave you with this thought. The picture on the left comes from a chap called Richard Wilkins, who showed me this picture of his spaghetti of wiring. And basically, and somebody else said to me, don't let this happen to you. You can see when you've got the fibers coming out of the box, yeah, you do end up with a spaghetti somewhat, but it's only one fiber per light, and it's very easy to trace those, and so a much easier system. Couple of last slides here. So there's my wife on the day after I had a birthday sale, and but we said really it's really important to have social distancing. So she does all my packaging for us, so she said, well, let's put them out in the driveway before the postman picks them up, and there they are. Well, we're all dealing with social distancing, and I want to thank my grandchildren, Benjamin, David, and Austin, my son-in-law, Joel, my daughter, Heidi, my wife, Shirley, and of course, I'm here as well. And I want to thank you for your interest in the system. They do, by the way, the grandchildren do most of the manufacturing together with my wife of the product. So, but my most senior person in the business is my grandson, Austin, our senior dwarf, as we call him. He's off to college very soon, so we're going to miss seeing Austin, and we're obviously training up the others to become our engineers in the place of Austin, at least until he comes home on his vacation times. So, thank you so much for your time watching this. I hope it's been helpful in understanding some of what you need to do with lighting and so on. And now I'm open to question and answers. Okay, thank you.
Okay, Michael, that was a great video presentation there. If you want to close it out, and then we can go to Brooks for any questions out of the feed.
Thanks very much, Brad. Well, great. I hope you've learned a little bit about what we're up to. And I said at the beginning, this is not a commercial presentation as much, but of course, it's always good to be able to get products a little bit cheaper at a time. And you saw that I got a 15% discount going on the Lamplighters at the moment. And our site is kind of a bit clumsy. It doesn't allow me to put another discount in there, but I want to offer a special NMRA discount, and it really is, I don't know if you can see that, but it's 15% off on all the lamps for the rest of this month. And all you do is you have to put in the code NMRAX. You can use a little x, a big X, I don't really care, capital NMRA, and that'll give you 15%, but you're going to have to order it separately from, say, a Lamplighter, the light source. But if you do that, I will combine those so you don't pay double shipping, because that's an easy thing for me to do, because I'm in charge of customer service and sales and marketing and the company. So no worries about that. And that's good till the end of June, right? So take advantage of that. That'll be great. And I also just want to, you saw that Lamplighter, the Lamplighter FL, as we're calling it, which is, just going to find mine. Yes, this new box that we're just about to launch. And I just wanted to really give credit to Jim Lewis at Model Train Technology, because we've worked together very hard on this, but we're really licensing that from Model Train Technology. So over to you, Brooks, for all the questions you can imagine.
Well, we got a few. So first question is, do you need anything special to do anything special to the ends of the fiber in order to use them?
Great question. And the answer to that one is no, you don't need to do anything to the fiber. So let's say I've got a piece of fiber and I've got it here. All I'm going to do is just cut the end of it off. I can't even see where here we go. Yeah, so I'm going to use a pair of shears, cut the end of it off, and I will just take my Lamplighter and stick it straight in. And I don't actually have to do then anything with it to treat the end of the fiber at all. That's the beauty of it. Just cut it and go.
We were talking off the video here, and you could scrape the side of the fiber and do some neat lighting effects too with that. Is that right?
Yeah, that's exactly right. In fact, up on our site, if you go to our site, which is www.dwarvin and you go to our customer showcase, what I've tried to do is put together a whole load of customers' images up there. And there's one where a guy has actually done a beautiful neon sign over a cinema. So it's actually a Woodland Scenic Cinema. But what he did was he put our fiber through, he scraped it so that, in fact, he scraped it so that there was less scraping at the beginning, more at the end, so the light was pretty uniform coming out of it. And it's a great shot. I was yet to meet him and find out how he actually did it and let me see his layout a bit more closely. It's actually an N scale, so you'll see that on the showcase.
Cool. So you just cut the fiber with regular shears, anything special, just flush cutters?
Just, yeah. So never use something that's got a blunt or an end that just cuts like that. So normally wire cutters are going to be cutting like that. You want a shearing action, and it just slices it. So you can use the end of a set of wire strippers. I actually use a zircon tool. The other is if you're laying it on a bench, the best tool to use is an X-Acto knife. Just go slice through it. What you'll do is you just look at the end and you see it's a nice shiny end. We're done.
Cool. What's is there any distance limitations to the fiber?
That's a great question because, yeah, people often want to know, well, can I run it through my layout? Can I run it 30 foot even? So it's funny when I'm at a show, Brooks, one of the things we do, we always have a piece of 30-foot fiber hanging up. We stick one end into the lamp lighter, the other end sort of shine it at the person. They go, oh, that's plenty of light. And the reason is, that's why fibers are used for transmitting the data. The data we're probably using right now is over fiber, because once the light gets into it, it isn't coming out easily. That's the beauty of the fiber, actually. The difficult part is getting the light in. That's my invention. Then it just runs through it. So that's sort of, it's just then plug and play, so to speak.
So you're just selling the light source itself, and you can source the fiber from other places, or do you sell that as well?
Yep, you can source it from other places. What I found though was the fiber that we buy, and I'll show you that. It's actually from Japan. It's an Esker fiber. Yeah, there it is, from Japan. That's probably the best fiber. The only problem with that, you're going to have to buy it about a mile of it. In fact, this is it comes on a huge big reel. And so what we do is we take that and we cut it down into 30-foot pieces, so that it comes, looks something like that.
Mm-hmm.
And that way, or we can, a customer yesterday just bought 100-foot of it, right? So we just wind it up for 100-foot length. But you have to be really careful. We did buy some Chinese fiber one time, and then we ended up finding that if we took this and we did something like this with it, it cracked. I mean, oh no. And there it was. I had to throw 2 miles of fiber away. And I just went, I'm not touching that. I want to go for so we decided to go for the top of the line stuff, because it's just not worth messing with it. Just have good stuff.
So how would you get the fiber comes up in one of those little light poles, say like the crossing flash, or how would you get that to bend 90 degrees to come out?
Hey, that's a great question too. So, yeah, I went on the internet and I went, okay, so how am I going to bend fiber? And the answer came out, oh, it's easy. You just use a hot air gun. Well, if you're smart, you use a hot air gun and you do it very gently. But if you're like most of us, you just apply a little bit too much heat and the whole fiber goes, right? It becomes a little piece of cooked spaghetti. So what I tried to do is I just, okay, boiled some water, stuck some fiber in it, and I stuck it in a tube at first just to see what would happen. Absolutely straight as a die, because when it comes off a roll, it's always somewhat curved. So I said, okay, good. So you can actually use then boiling water or very hot water to do that. So to make a good bend, what I do is I'll take a piece of aluminum tubing and I'll put one piece down here and I'll put another piece at the end, put it in some boiling water and just push it against a wall until I get the bend I want. And I can put it at the other end into my lamp lighter so I can see that I'm not bending it too sharp. Too sharp and you will lose light, of course. But if it's not too sharp, you can get a really nice, easy bend out of it. And once you pull it out of the water, it cools off almost instantly, and it's going to stay that way. So great question for that.
Cool. Well, I got two more questions I'd really like to cover because I think they'd be important. What about dimming? How would you go about dimming the source coming out?
Got it. So when I'm looking at my lights here, for example, if I want to dim a light back there, what I'm going to do is I'm just going to remove the light slightly, the fiber slightly out of the lamp lighter. So it's very manual. I can't do it automatically at this stage on that, but I can at least do it fairly quickly from the light source. So it's, in fact, when I first did a presentation, somebody asked me that and said, oh yeah, I can't do that. And then I realized, oh, you fool, of course you can. You just pull the fiber slightly out.
Cool. Okay, last question. So it looks like there's some Christmas lights in the pub.
Yeah.
What size fiber would you use for that? And then also, how would you go about coloring the ends? Can you do different colors on the ends?
Yeah, so very easily. So what I did is I used a one millimeter fiber there. And all I did was I took a pair of these nippers and I just sort of go around it slightly and I'm damaging the fiber. And so light starts to escape from those damaged places. And then I just grabbed some Tamiya paints, some translucent paints, green, red, in half an hour, I got my whole pub lit with about 100, what looks like 100 LEDs sitting on it. So pretty simple.
Yeah. Yeah. And trying to run wires for that many LEDs would be a nightmare.
Try soldering them. Yeah, no,
Yeah.
absolutely. Yeah.
Yeah.
So I paint it first. I paint the fiber, then I nick it, then I just paint it. Job's
Yeah,
done. So,
and we were talking about the great application for this is you can get light into places where it'd be very hard to run a light, or put an LED in. So,
Right.
this product's really innovative.
So I'll give you one example. So here's our flasher unit that we've got, which I think I mentioned just a moment ago. This one, right?
Mhm.
And I've got it doing different types of lighting, but I've got a train signal back here. I don't know if you can see it from there, but I've got a trigger on this, and I'm going to trigger that. So I can trigger that on the box. And I don't know if you can see that. But there's the railroad crossing. So we're actually going to be coming out with the railroad crossing pretty soon. That's my grandson's last project before he heads off to university, is to get that done for me. So we've got that. We'll then have trigger systems, both from Model Train Technology and Iowa Scaled, and that way you can have the whole shooting match all in
Cool.
one box.
Cool. Well, we're out of time here, and we need to go so we can get the next clinician in. But I appreciate you coming in, and that was a very good presentation.
Thanks very much, Brooks. Appreciate it.
Yeah.
Bye for
Thank you.
now. Enjoy.